Hi everyone, I'm Louise, and today we're going to talk about optimizing your Python and Django apps with Postgres superpowers. So a little bit about me before we start. I am a Python developer. I work at Microsoft in the Postgres team. I used to work at Citus Data, and we got acquired by Microsoft about a year ago. I love both Postgres and Python. I've been working for 8 years with both of them, and I just have so much fun with it, fishing information from Postgres and feeding it to Pythons. This talk is initially was a workshop that we were supposed to give at PyCon this year, and I'm very sad that I'm not going to be able to be there. And hope that I will meet all of you next year or at other conferences in real life and hopefully have feedback from you about this workshop. So I enjoy complex and modern SQL, and that's the subject of a lot of my talks. And overall, I really encourage developers, whether it's Python or Ruby or other languages, developers to use the database at its full potential, especially Postgres, because really often when we work with ORMs, we tend to, underuse the powers of SQL. So a little bit about what we are going to go over today. So first, I want to kind of go into why we end up with performance issues. So what can cause them and how to, catch them. So what tools can you use to fish those problems? And then we'll go over 4 case scenarios that of, things that can happen in your application and in your database that can cause performance issues. So it will be loops, limiting query set, pagination, and overall looking into slow queries. So first, what can cause performance issues? ORMs are very useful. We use them a lot, and I would say that the main thing that I like about it is that it helps us build applications in very short amounts of time. However, I think that we need to be careful. One thing that can happen and that can cause performance issues with ORMs is that your ORM might be executing queries you might not expect. And if you don't look into your logs, then you wouldn't know about those queries. The second thing to look into is that the queries might not be optimized. And if you don't look into it, if you just, look at your Python code, you won't know about them. So we really need to, be careful about our ORM, our database, and the link between the two. And finally, sometimes the fast queries that you have in your dev environment when you're working locally might behave very differently when your database is much, much bigger on production and when you have load on that database. And this is also something important, something that might not seem a problem in your local environment might become one later on. So how can you prevent that? And how can Postgres superpowers like a seahorse with a cape help you with performance issues? So the first tool that I want to introduce is pgstat-statement. It's a Postgres extension, so you install it using create extension, and it's going to help you track statistics on queries that are executed on your server. So the way it works is that it's really going to save the queries into a table and tell you, how many times and how slow the query were. And I'll give you examples of what you'll find into the pgstat-statement table. So it's great to catch slow queries. I really could recommend you using it on your production environment as well as your dev environment. In your production environment, you should not be worried about performance issue with pgstat-statement. If you want to configure the number of queries that you are tracking, you can through configuration file, the PostgreSQL configuration file. And so I really recommend it because it will help you track slow queries. If you're working on a cloud provider for your PostgreSQL, like if you have Azure Database for PostgreSQL, it is actually installed and enabled by default. And that's the same with a lot of the cloud offerings. So how to use pgstat statement. Here I am getting the kind of this 100 slowest queries here. So I select the columns and I order by mean time, limit 100. So what it gives me as a result is a record like this. Here it gives me the total time, the min time and the max time, and the number of calls. So this query, select count star from this table, has been executed 3 times for a total time of 643 milliseconds. If you're using Azure, there is actually a tool called Query Performance Insights that is actually using pgstat statement, and it gives you, statistics like your top 5 queries by average duration, aggregate, and so it aggregates in the last 15 minutes. And so if you want to use pgstat statements and you want to look a little bit into an interface, this can help you. The other thing that you can have is the performance recommendation. So here it's going to give you basically 2 suggestions. One can be what index to create. So if you have slow queries, what index could help you improve the performance? Or kind of the opposite, you might have indexes that are redundant or that are not used and that would be slowing down your writes. And so that's not something that you want. The second tool I want to talk about is the Django debug toolbar. It's a tool that I use really pretty often, I would say. And the way it works is that in a template, you integrate it, and it's going to list the queries that are executed in that template and in that view. And it gives you the explain plan of the query. Today, I'm not going to go too much into explain and what it is in SQL. However, I'll just show you one example at some point, and I really encourage you looking into explain because it can help you so much in figuring out why a specific query is slow. The other thing that Django Debug Toolbar does is that it helps you trace back the queries. So if you're kind of confused about where a query comes from and why it's executed, it traces it back to your code, and that's very helpful. You should only use it in debug mode. So when debug is true in your Django settings, you should not have that in your production environment because, otherwise you let everyone see your code and your queries. So that's not great. Third, so logs in PostgreSQL. The reason I mostly use Postgres logs. As much as I love the Django debug toolbar, it's sometimes not enough for various reasons. One is that if you work with different environments, so if you have a Golang MPI and you also have a Django app, or maybe part of your team is working with, Rails, using the Postgres logs, it won't change anything. You won't have to find a different tool for each of these languages. You just need to configure your logs, and that's really cool. The other reason why Django Debug Toolbar is sometimes not enough is, for example, if you're in your template, you're executing some Ajax, some React that is calling APIs, and so you end up with queries that won't be displayed in the Django Debug Toolbar, which makes Postgres logs even more useful. So to configure your logs in Postgres, here are the settings that you want to change. So you're going to put log statement to all and the logging collector to on, logmin duration statement 0. This way, you're going to be logging absolutely every single query happening on your database. However, be very careful about it because in your local environment, this is great. You should always look into your queries and see all of your queries in your local environment. However, on production, you wouldn't want to do that because you would end up with very large log files. Like, for example, let's say you configure that on your production and you have, 100 people connecting on your app and you have thousands and thousands of queries logged in your file. And that would also create different problems, but more disk problems than Postgres problems, but still. So now the first thing that we are going to talk about here is loops. Loops can often be one reason we have performance issues, which is why I wanted to talk about it. Before I dive into it, as I was mentioning, this was supposed to be a workshop. So we were supposed to all sit together in a room and have fun improving an app together and going through those performance issues together. As we can't, given the circumstances, here is the link to the GitHub repository where you can find the app I built for this workshop. So if you clone it, you can install it, you can run it, and you can improve or test what I'm going to show today. So about the schema. In this workshop, we're going to mostly focus on campaigns and ads. I just want to give you an overview of what this application is. So we have companies and employees, and each employee can connect to the app and see an interface. And a company has campaigns. Campaigns have ads, and an employee can work on a campaign and be a collaborator. Each ad can generate clicks or impressions. So let's see how it looks like. So here I'm scrolling down my campaigns, and on the side I have a menu with links to the ads of each campaign. So this is a pretty standard application. Here is the code for this view. So I have a campaign list view. It's a generic list view in Django, and it's logging required, obviously, because only employees should see the campaigns. And I have a query set here that I'm overriding for the model campaign. And I am filtering here the query set on the company of the logged in employee. So here I have company equals self request user employee company. So let's look into this view again and look into the Django debug toolbar and what information it gives us. Here what I can see is that I have lots of queries, 101 and 96 similar queries. So I'm going to trace back that using the Django debug toolbar, and I see that it comes from rendering my template. So it comes from the template code, which is where the SQL is actually executed here. So let's look into, again, my template code. So I know that it comes from here, so let's look into why. I have here loop, so for each campaign in the campaign, so in the objects of my list, I am showing the URL for the ad. So I have two loops. I have for campaign, and for each ad in the campaign ads all, I am displaying a link. So the reason why I have 96 queries is because I am doing this loop for 96 campaigns. So for each campaign, I'm going to have a query to the add. So that's why I have 96 campaigns, so I have 96 queries, and this is not great. To fix loops, Django provides two functions. Select related is actually going to do a join. We usually use it for foreign keys because it's joining on the foreign key column. And the second function is prefetch related. It's usually used for many-to-many or related objects, which is the case here because I have many ads for one campaign. So the way to use it is in my query set, I add, after the filter, I add prefetch related ads. And so now let's look into my queries. Now I only have 6 queries instead of 100. And I have a new query where I have campaign ID in and then the list of my campaign IDs. So I went from 101 query to 6 queries. And this is pretty good, right? A little thing about loops before we move on to something else. Catching loops on production can be really painful. It can be really, really bad for you. Imagine if you have, this happening with, 100 people connected, and so you end up with thousands of queries. So you don't want to catch loops on production. So really remember something. You should always look into your queries to make sure that you didn't forget a loop. The other thing that you should be careful about is that maybe on your dev environment, you're working on a very small set. Like maybe you have just, 5 campaigns in your dev environment. So you might not actually notice the loop until you're maybe on staging or worst prod. So you should be careful. And maybe if you've never done that, you could maybe look into pgstat statement and see the queries that are executed the most and see if maybe there's something odd and you've forgotten a loop somewhere. But again, you should really be careful about not letting this into your production. So just be careful about the queries executed during your dev phase and check loops. So second issue that I want to talk about is limiting what you're selecting. By default, the Django ORM selects all the columns. So when I do the prefetch related, here is the query. So I have a select and I have all the columns. I have ID, name, campaign ID, URL, target URL, impression, etc., etc., etc. I don't actually need all those columns. When you look at my menu, what I'm actually displaying is the name, and I have a link with only the ID and campaign ID. So the query that I should be executing should be something like select ID, name, campaign ID, where, but I should not be selecting all the columns. So Django provides a tool or a function called only that helps you limit the columns that you are selecting. Here, it might not seem like such a big problem, but you can imagine if I have, 30 columns and some of them are texts and you're pulling a lot of data that you actually don't need. And so the more data you're pulling, the slower your query is going to get. So to improve your page performance, limiting what you're pulling from the database to only the columns that you need will help you a lot. So don't let your ORM dictate what you select. Here is an example of how to use only. Here I'm doing a campaign objects filter with only name. But here, in the example that I had before, I am using prefetch related to, I'm using prefetch related. So to limit the query set, I need to do only on that prefetch. So what I'm going to do here is use the prefetch class. So I import it from DjangoDB models. And here I do prefetch adds. So again, I keep the name of the related table. And in the query set, I put only ID, campaign ID, and name. So that's how you limit selecting your columns. The third thing that we're going to talk about is pagination. I had 96 campaigns. I generated 1 million campaigns now for this company. And the page became very, very slow. I am not even showing you how slow this page is because it would take too much time and it would honestly be kind of boring for you. So just know that now my page is very, very slow because I'm pulling 1 million records. So why is paginating so important? As I was mentioning, retrieving 1 million rows is slower than retrieving 25 rows. It comes from, it being just more data to pull. So the more rows, the slower it's going to get. Plus, I was doing a prefetch related and it generated a query with campaign ID in and this list of value. And so if you have 1 million values in this in, it again also gets very slow. And of course, do you actually need to see all the rows? No, like you never actually need to see 1 million rows in one page. I don't know, as a human personally, when I look at a page, I can't remember 1 million information. So probably you actually don't need to pull everything. So Django has a paginator that helps you, with paginating. So the class takes care of splitting the query sets into pages. So let's look at the example that I'm giving here. I am taking this query set. So I'm doing a campaign objects filter, campaign ID equal 1. I order by ID. Now I'm initializing a paginator. So I pass it the query set and 25. 25 is the value I want to paginate by. The number of pages here is 40,000. So a paginator has a number of pages. I can here select my page. A page is an object. So I do paginator, so p.page1, and it gives me a page object. What a page object has is several functions. It has a next function that will give you a Boolean telling you if it has a next page. I have here, it's the page 1. Does it have its next page? Yes. Does it have a previous page? No. So has previous will be false. And it also has a next page number. So it helps you with, when you're going to do the HTML to paginate, it helps you build the URL for the next and previous pages. It also has an object list. I am here only showing 2 rows because it would be just too big to show everything, but it will have 25 objects in this object list. In Django, the generic view list view actually has a built-in way to paginate by just adding paginate by and the number you want to paginate with. So here I put it 20. And now let's look a little bit into the HTML for it. So I have here the pagination, just the HTML to have the previous and next pages. Here I put the previous link. So if the page has a previous page, I put the link to previous page number. Here it's the same for the next page. If the page has a next, I put the link to the next page. So let's look a little bit into, what it means now that I've put pagination. So now I only have 20 rows instead of 96. Yay! And I go to the second page. In the second page, I also again have 20 rows. And let's look at the queries. In the queries, I have now a limit 20, offset 20 when I do my select campaigns. It takes 100 milliseconds. Now let's go to the last page and let's compare the performance here. Now I have a limit 17 offset almost 1 million. I'm not going to read that number. And it takes 398 milliseconds, almost 400 milliseconds. The other thing that I have here is a select count. It takes 364 milliseconds. And let's go back to my first page to compare again. I also have 7 queries, and I again have this select count that takes 360-ish milliseconds. So this is a little bit of a problem in the way the pagination works here. So I have a count that is used by the paginator to determine the number of pages, and this count is slow. And the more rows, the slower it's going to get. So this is really kind of a red flag. If you have a slow pagination, look if you have a count. That can be a reason. The other thing that we've noticed is that we had a query with offset 20, limit 20, that took 100 milliseconds. But for the last page with offset 1 million, it was taking 400 milliseconds. The reason for it is the way offset works in PostgreSQL currently. So the way it works is that it's going to fetch the rows and skip the first n rows and return only the last 20 ones. So if I'm doing offset 20, limit 20, it's going to fetch 40 rows and return only the 20 last. When I'm doing offset 1 million, limit 20, I'm going to be fetching 1,020,000 rows and skipping the first 20. So those rows that I'm still fetching are the reason why the higher you get in pages, the slower your query is going to get. So you can see how problematic that can be, especially if you have much, much more than 1 million. So what is the solution to it? That's why I want to talk about Keyset pagination and why I encourage you to switch to Keyset pagination instead of offset n, limit n. So the way Keyset pagination works is instead of having limit 20, offset 20, it's going to add filters on your order by fields. So here I'm ordering by ID. So I'm going to, in the second page, have queries with ID bigger than 20, let's say, and order by ID, limit 20. If you want to learn a little bit more about how Keyset pagination works, and especially if you have more than one field that is your ID, you can read an article by Marcus Wienand on his blog, usetheindexluke.com. And here is a short link to it. He explains, a lot about offsets and other tricks to get better performance. So Keyset pagination in Django. I want to show you that it's pretty easy to actually switch to Keyset pagination and improve greatly your performance. So there is an app that has been written to simplify using Keyset pagination. It's called Django Keyset Pagination Plus. The way you do it in your code is that, so you import the paginator and a paginate mixin. The mixin, you put it in your class mixins. So here I'm having still my login required mixin, paginate mixin list view. And I just add on top of paginate by the paginator class Keyset paginator. So let's look a little bit into the result of using Keyset pagination. Okay, so I had 7 queries, now I have 6. I don't have the count anymore, so that's great news. And here I am in my last page, and this is, I have the ID filter over 1 million, and it's only taking 100 milliseconds. And now overall, this page takes 628 milliseconds to load. And it used to be over 1.2 seconds. So I split by 2 the time spent in the database. And 600 milliseconds is still slow. And of course, you could, improve more by adding indexes, by analyzing why the queries are slow. But already dividing by 2 the time spent in a page is already pretty good. So now, fixing slow queries. So I don't really have time to go too much into it, unfortunately. However, I am going to give you resources to go further into this issue. So just a little bit about it. We're going to use again the pgstat statement to find the 10 slowest queries. One query that I find here is this one. So I do select star from the campaign where archived is not true. So I'm trying to fetch over and over and over again a query that is not for campaigns that are not archived. So what can I, improve about this query? I'm going to use explain by doing explain and then the query. And it's going to give me something called a query plan. And what a query plan is basically, what is happening in Postgres, kind of how is Postgres processing the query. I can't dive in too much into explain. However, there are really great resources about explain. So I encourage you to look into it. There are some conference talks that are explaining it. So it's if you look on Google, you can pretty much find anything about it. So here what I can see is that it's doing something called a sequential scan. So what a sequential scan is that it means that instead of using an index, it's going to actually scan the entire table and apply filters. So this is generally, it's not always bad to have a sequential scan, but in this case, I can think, okay, I'm missing an index. So what am I going to do? Today, just for the sake of the example, I want to show you partial indexes. So partial indexes are in Postgres a way to create an index with a filter like a where clause, exactly like on any query, but on an index. So they are supported by Django. You could use raw SQL to create your index. That completely depends of you and how you handle indexes in general. But if you want to use the Django ORM, it is supported. So here, what I do is I put it in my campaign class. And what I do is that I add a condition on that index on archived equal false. So now the query takes 100 milliseconds. Just to give you a comparison, the query took 219 milliseconds. So I already improved it a little bit. If you are curious about indexes in Postgres, I gave a talk at DjangoCon this year. DjangoCon is such a wonderful conference. I really loved it. And I talked about, what Postgres offers in terms of index types like GIN, GIS, B-tree, how to choose between those and how to improve your performance using the right indexes. And I also go into the options that you can get. So if you're a little bit curious about partial indexes, I talk a little bit about that, and I talk about multi-column indexes, unique indexes, etc. So here is the link to the YouTube video of the talk. So now, let's say you have the perfect code. You've optimized everything. You have no weird queries. You created all the right indexes. You have the perfect amount of indexes, not too much, not too not too many, not enough, etc. Like everything seems perfect, but things are still slow. Or maybe it's getting slower and slower, but you haven't changed anything. So this is very confusing. And it can come from many things. Like it can be because of you have more traffic on your app. Maybe because of that traffic, your CPU is bloated, you have low memory, maybe your disk is filling up. So at some point, maybe you are in this situation where your hardware is not enough. And so that's a good moment to scale up. So scaling up meaning adding disk, CPU, etc. But you might wonder how you know that it's a good time for you to scale up. I recommend you looking at this talk on how to debug things when Postgres is slow, when Postgres is not working how you want, when everything is wrong. And what it goes over the tools that you can use to debug Postgres and what conclusion you can draw from, okay, high parallelism, high CPU, or low CPU and high parallelism, etc. Like it goes into the different case scenarios and help you understand what is going on your database server and whether it's time or not to scale up. And now, what if your app is a big success? Okay, now maybe scaling up is not enough anymore. Maybe you have hundreds and hundreds of terabytes of data, and having everything in a single node Postgres is not an option anymore. Then you can scale out. You can scale out using Citus. Citus is an open source extension to PostgreSQL. It helps you scale Postgres horizontally. Here you have a link to the GitHub repository of Citus if you want to look into the open source version. And what Citus does is distributes the data through on different workers, and it also distributes your queries. It's great for multi-tenant applications. We actually in Django have a tool to help you with your Django app and working with Citus. And from your app side, it actually looks like a single node Postgres. So when you connect to the app, like in your Django settings, you don't have to change a lot. You just change your connection string to connect to a Django, Citus, sorry, app, server, sorry. If you want to have managed databases, we have Hyperscale Citus, part of Azure Database for PostgreSQL. So just a little bit about how it works. So here I have my application sending data to the coordinator. The coordinator sends the query, sorry, it sends a query to the coordinator. The coordinator sends the query to the workers, it redistributes it using better parallelism of your CPU. So it uses your hardware a little bit better than a single node would. And your workers are going to return data to the coordinator that is going to return that to your application. So that's how, in big lines, how Citus distributes a query. If you want to, learn a little bit more about Citus and how to use it, here is a quick start link, so you can, get started with Citus in Azure. So conclusion, here are the 8 things that I want you to remember about our amazing Postgres. First, pgstat statement to find slow queries, or in general, it will help you debug your queries, or more than debug, more like catch what is wrong and find slow queries, really, and so find queries that have been executed a lot, and that can in general help you understanding what's going on your database side. Django debug-toolbar is a really cool tool. It might not be enough for you, especially if you are not always using templates and views to get data. So in which case, Postgres logs is what I would recommend 100% all the time because it gets you visibility into the queries. So please turn on your Postgres logs. This is going to help you always. Be careful about loops. Yeah, don't catch your loops when it's too late. That can be a real bummer for you if it's on production. Don't let your ORM dictate what you're selecting. Think about using only. Think also about using raw SQL sometimes. That could help. If you are already using pagination and you're using pagination with offset, try to use Keyset pagination. It's going to help you a lot. If you're not using pagination, lucky you, you can start straight ahead with Keyset pagination. Indexes can help with performance. Creating too many indexes or indexing every single column you have could also hurt your performance. But overall, understanding indexes and knowing what indexes Postgres has will help you. And finally, sometimes you can improve as much as you want. Sometimes it's just your hardware that is not enough. And in this situation, scaling up or scaling out will be a good solution for you. So thank you for your attention. If you have questions, you can ping me on Twitter. I'll be happy to answer any questions you have. And here are the links to the resource I gave in the previous slide. So here's the quick start docs for Citus and talk on debugging Postgres I forgot to say that it's from a colleague, Will Lineweber. And the link to my talk about indexes, the GitHub for the app. If you're curious about testing what I've been showing today, you can go on GitHub and clone it and have fun with it. The Git repo for the site is open source. And if you're interested, you can join the newsletter. Thank you. Bye.